I wonder why. I wonder why. I wonder why I wonder. I wonder why I wonder why. I wonder why I wonder. These were the words of Richard Feynman, who has sown the seeds of a new technology unknowingly. In this video, I'm going to talk about nanotechnology from ancient time to nowadays. So, the purpose of this video or the talk is very simple. We all know or we believe nanosciences and nanotechnologies is a new concept or the new trend developed at the end of the 20th century. But it's not true and certainly not. There are a lot of evidence that point that nanotechnology exists already in the nature and the mineral form, vegetal and in the animal worlds. So I'm going to give you an overview about the technologies with applications from ancient times till the present. Let me introduce what is a nanoscience. Actually, the concept of nanoscience was unknowingly introduced by Richard Feynman in his visionary famous talk at Caltech University titled There is Plenty of Room at the Bottom. He said, the principles of physics, as far as I can see, do not speak against the possibility of maneuvering things atom by atom. And he has also declared and challenged the young researchers write the entire 24 volumes of the Encyclopedia Britannica on the head of a pin in 1960. So this was the first seed sown for a new technology called nanotechnology. And this man, the professor from the University of Tokyo, Japan, was the first one to employ the word nanotechnology, Norio Taniguchi, in the year 1974. And he envisaged this technology as a production technology, allowing us to reach ultra high precision and ultra small sizes of approximately 1 nanometer. But there was a big stagnation. But the technology developed with the advent of the two technologies, that is the scanning tunneling microscope, that is STM, and atomic force microscope AFM, which was invented by IBM in those days. So these two technologies allowed the researchers to probe more into lower the scale. Okay, what are nanomaterials and nanotechnologies? A nanomaterial is an object which has at least one dimension in the nanometer scale, which may range from 1 to few hundred nanometers. These materials are termed as nanomaterial. Generally, we can classify these nanomaterials into two types. One is belonging to a natural origin, which includes proteins, viruses, bacteria, nanoparticles produced during volcanic eruptions or during forest fires, nanostructured crystals occurring in nature, minerals, etc. Anthropogenic origin. This may be due to human by non-intentional means or by intentional means. By non-intentionally, nanoparticles are produced from diesel or by petrol combustion and in fuel burning from the power station and from incinerators. Another category, intentionally through a defined standard manufacturing process. Then what is nanotechnology? Nanotechnology is nothing but it is a traditionally or a common word collectively called for the materials made intentionally by humans only. So there are a lot of methods by which we can make the nanomaterials. Okay, why this technology is so attractive these days? This technology is very attractive because the demand for the decrease in the size of the components, there was a need for the decrease in the size of the electronic components. The semiconductor industry needs a very, very small components, and that is the miniaturization of electronic materials. And these materials proved to be a promising material for engineering and medicinal fields due to the peculiar properties of the matter at the nanoscale when you compare it with the properties of the similar materials and the larger scale. So, despite this peculiar properties, they exhibit new chemical, optical, electrical, and magnetic properties and quantum effects. Okay, so we all believe this nanotechnology is a recent development in the science and in science in recent days. But no, it has been existing in ancient tradition for a long time. So the basic overview of this, or the main overview of this talk itself, is how this nanotechnology has been in use from ancient times. The first evidences that point to the use of nanomaterials or the nanoparticles is began in the 14th and 13th centuries before Common Era, that is before Jesus Christ era. So this all happened in Egypt and Mesopotamia, where the glass industry started making glasses which possesses a red color, and this red color of those glasses are primarily because of the presence of the metal copper nanoparticles and nano cuprous oxide. And here there is a blend of antimony which served as a pacifier there, and this antimony acted as a reducing agent. So all these red color might be because of this nanoparticle which become, knowingly or unknowingly present in the clay, become a nanoparticle when during the heat treatment process involved during the glass making. So such kind of ancient glass pieces were found in these regions until 6th century before Common Era. So the next the very famous example, or the very famous evidence that nanomaterials does existed in a even in the ancient days is this is called LYCURGUS cup. This is a fantastic glass cup or glassware or in glass art done by Romans in the 4th century, which depicts the life history of legendary king Lycurgus. Actually, this cup is not famous for his life history or the glass work or the artwork. This is kept in the British Museum, London, which belongs to the 4th century Common Era. And this cup exhibits a very remarkable aspect of a light, and that is called as a dichroism. Di means to croism, means two different colors. This cup exhibits two different colors. When you look the cup from outside, it resembles jade with opaque greenish yellow because of the reflected light. But when you lit this cup inside the lit it from the inside, the cup glows with a transparent red ruby color, which is because of the transmitted light. So the X-ray analysis and the chemical analysis done on this reveals there are the traces of gold and silver particles in the ratio of 40 parts per million, and silver in 300 ppm in the glass. And when probed more by the transmission electron microscope, it revealed there is a presence of nanoparticle silver gold alloy in the ratio of silver to gold in the 7:3 ratio. So these glass manufacturers might have used this metallic salts which is dissolved in the silicates, and these particles would have turned into a colloidal dispersion or a nanoparticle during the heat treatment. And the color of the glass is due to the metallic colloidal dispersion and the combined effect of absorption of light by gold, which gives the red transmission, the red color when it is lit from the inside, and the green reflectance of is the scattering of the silver nanoparticle when light falls on on the cup, that is because of the reflected light. This effect we call it as a Lycurgus effect, and this effect is not unique in all the glasses. It is a very very rare effect which is exhibited in the Lycurgus cup. This points out that this nanotechnology or the nanoparticle making is already in the ancient times. The next example which reveals the presence of the nanotechnology is in the between 4th and 12th century. We can see the Roman Christian churches have the walls decorated with some different kind of mosaics or tiles, and still those tiles are called as tessera. This tessera looks like a flush toned glass even today. So the reason for this is has been revealed through an X-ray studies, which says there is a presence of nanoparticles between 10 to 35 ppm. So these gold nanoparticles are responsible for the glossy look of this gold ruby glasses. And after this 12th century, we can call these period as a medieval period. During this medieval period, you could see the churches in the Paris glowing with the stained glass windows. So during this medieval region or the medieval period, the red color glass and the yellow color, the red color glass and yellow stained glasses are very very famous. It is found in all the churches throughout the France. So this is because of the incorporation of the gold colloids in the glass, which turns the glass into red, and these yellow stained colors are because of the presence of the silver nanoparticles. So aren't they not beautiful? So the next evidence, so far these are the home crafted colloidal solution. The systematic study or the systematic combination was done by Cassius, Andreas Cassius of Leyland in the 17th century. He prepared purple of Cassius, that is, he has brought or he has wrote a book. There is an evidence. There is a book titled De Aura, in which Cassius has explained how this gold gets its purple color, which is called as a purple of Cassius. And this is how he obtained. He dissolved a gold metal in an aqua region. Aqua region is nothing but it is in concentric nitric acid and hydrochloric acid, and the precipitation of metallic gold by a mixture of tin chloride, that is tannous or a stannic chloride, will give you the colloidal gold, which gives the red color to the colloidal solution. Again, this is nothing but this is also pointing to the presence of the gold nanoparticles. When you lower down the size of the gold particle, or when it gets into the colloidal solution, the gold color of the auric acid or the gold goes into a deep red color. So this is called as in purple of Cassius. His formula or a trade secret is very very it was the biggest trade secret on those days, especially in the glass industries and ceramic industry. And this formula, the purple of Cassius, was used by the French porcelain workshops. Still this exists. Still this is maintained by some royal family and the Royal Society. The manufacture Royal de Sabres, they have made so many porcelain wares. Especially the queen tried to replicate each and everything in the royal palace with this technique. And one of the most famous among them is Rose Pampadar. See, all the cookwares, all the vases are glazing in the royal palace with this purple of Cassius technology. We all know. Okay, that happened. Cassius of the purple of Cassius was in the 17th century, and in the 18th century, the state secret of the purple of Cassius was brought to the China by the missionaries or the Jesuits who carried the who wanted to spread. Came as missionaries to China. During this 18th century, the Qing dynasty, we all know the Chinese peoples are already the king and queen makers of the porcelain and the all cookwares. They started using this purple of Cassius technology and produced cookwares, vases, using red and pink enamels. One of them is the family rose production, which is so famous during those days. Again, these wares are glazing because of the usage of gold nanoparticles. And the next evidence we get from the ancient time is Damascus steel sabres, which are used in 17th century. The sabre is nothing but it is a sword with curved structure, which is used for cutting the edges. So I hope Rajamouli could have got the inspiration from this only. So these sabres exhibit extraordinary mechanical cutting properties and they have sharp cutting edges. The analysis revealed the presence of carbon nanotubes and cementite. Cementite is nothing but it is a mineral having Fe3 carbon nanowires. How did these material got nanowires? The materials, I mean the combination of the cementite and the carbon uh, during the heat treatment, that is during forging, these material have turned into a nanomaterial. This happened, or this is predominantly the catalytic formation of carbon nanostructures from hydrocarbons. The next example is the Mayan Blue. The Mayan Blue is a cyanic blue color, which is found in potteries, murals, and ceremonial artifacts in the Mayan civilization in Mesoamerica. So, the fascinating character of the Mayan Blue is they are resistant against acid attacks and biocorrosion. And scientific analysis revealed there is a presence of needle-shaped crystallite of polygorxite, a clay. The clay has a superlattice nanostructure with indigo molecules incorporated. We know what is an indigo. It is a plant which gives the blue color. So the presence of the ferrous, chromium, manganese, titanium, and vanadium in the clay material also adds to the resistance of the paint. This is also a marker that was there in the Mayan civilization too. So actually we could call this as the birth of the nanoscience. So we know Michael Faraday. We cannot do any kind of physics, any branch of physics without Michael Faraday. He has touched in many branches of physics from electrolysis, electromagnetism. Even he has touched this nanoscience before its birth. He was the first one to synthesize gold nanoparticles in 1857, that is in 19th century. He was amused and fascinated by the deep red ruby color of the colloidal gold. So he thought the optical properties of the gold colloids differ from those of the corresponding bulk metal. So he made a colloidal solution of gold by reducing gold salts with phosphorus. This was the first observed effect of quantum size. This is the real birth of the nanoscience he has unknowingly he has done. Okay, so there are a lot of evidence that the nature that is the nano inspires the human beings. So this is NACRE. So NACRE is nothing but it is in shells of the mollusks, that is the biological composite found inside many mollusk shells formed by alternate mineral platelets. So that is the calcium carbonate platelets in an aragonite form. In aragonite form, calcium carbonates exist in three different forms. I think it's dolomite, aragonite. So one of this form is an aragonite of micron sizes and submicron thickness, and each layer is separated by a biomolecular glue. So these highly organized design at multiple length scales exhibit an outstanding mechanical performance which includes stiffness, strength, impact, resistance and toughness. and this effect we call it as a nacreous effect. And these nacreous effect inspired the scientists or the researchers to make an bio inspired ceramics having the same hardness, stiffness, impact resistant and toughness. And we have a beautiful butterflies. The colors of the butterflies are directly combined, connected to the fine structure of their wings. So the wings are made up of when probed using x-rays and chemical analysis, it reveals the wings are made up of multi layers of nanostructures, and these nanostructures behave as a diffraction grating. When light enters these grating, they create interference, and these interfered light produces the vivid colors. That's why butterflies have beautiful wings. And the next, the water droplets on the lotus leaves, that is the water repellent property of the lotus leaves. You can see the leaves have an n number of hairs, hairs, or you call it as an epicuticular wax crystal. It's the leaves on the outer layer of the leaves have an epicuticular vast crystallites and n number of hairs over the rough surface. When water falls on it, and they collect, they get water repelled from it, and they themselves clean their dirts. They have a self cleaning activity. Then feet of geckos, they have a strong surface adhesion, and they can swim upside down or they can walk upside down against gravity. This is because of the feet. The feet of the geckos are made up of nanostructures. So all these natural phenomenon has inspired researchers in many ways to produce a new new devices, or use it in many applications. So there are many natural nanomaterials are of great interest, not only to understand the amazing properties of biological materials, but also to gather inspiration for the design and engineering of new materials with advanced properties. So, okay, let's quickly move on to what is the status of the nanomaterials at present. So, these nanomaterials are widely used in nanoelectronics and nanospintronics. So, the nanomaterials, the semiconductor industry widely uses this nanoelectronic technology, and the the magnetic properties at the nanoscales was completely used by nanospintronics. And nanomaterials are highly used in fuel cells. The fuel cells are useful in maintaining a green environment. They are alternate solution to the current fuel crisis. But this technology is not a cost effective one. Researchers are working on it, and it is used in car industry and automotive remediation. So the car industry, to produce an to produce a material, so that during the collision they can withstand that collision. They are trying the paints new materials to make the car, so that they cannot be crashed during the accidents. And in the cosmetic industries, we are using the nanomaterials in the form of shampoos, lotions, sunscreens, especially the titanium oxide, which has a greater absorbent power towards the ultraviolet rays, thereby protecting our skins, our natural skin. And in the textile industry, as a strain remover. And in buildings and the self-cleaning surfaces. And we can use these nanoparticles for depollution, and nanomedicine can be used in the diagnosis, therapeutic, and in the cancer treatment, hypothermia, photothermal therapy, or the cancer treatment technique, where in the conventional technique chemotherapy, even the healthy cells are subjected to radiations to destroy only the cancer cells. The techniques like hypothermia, photothermal therapies are used, and photosensitization by metal nanoparticles, nanorobots. This nanorobots is still in the initial stages. Still, it is in the literature and in some movies. So it will take a very long time to make these nanorobots. So all these are the present applications of nanomaterials. So finally, I can conclude, yes, we are living in the nano revolution from the ancient age to till now. So, with recent technology, there are huge developments in this field, making potential applications in materials, chemistry, catalysis, electronics, biology, and medicine. Nowadays, these nanotechnology is not only confined to research laboratories, but it has touched our lives in all the ways. It has reached in our everyday life, starting from the lotion, varnishes, paints, nanomedicine, or semiconductor industry. So it is touching our lives in all the way it can, and it has also influenced the global economy tremendously. Though the technology has grown a lot, there is still the limitations for it. There is a greater concern over their dissemination in nature, how they get dispersed, how they can be like an e-waste. We have how this nanoparticle can be recycled or reused, and their potential toxicity. There are still a lot of trade secrets behind these nanoparticles or the nanomaterials, and the common public wanted to know what is the safety. They wanted to the demonstration of the safety, and there are fears, phobia towards whether this technology may harm us, and still lot of social debates are going for the acceptance of nanotechnology. So the biggest challenge before the scientific community is the integration of the sustainable development and environmental impact. And this talk is the adoption of a paper by Delphine Shaming and Hind Remita, which they presented in a conference at the University of the Paris by titled Nanotechnology, Irrational Fears and Realistic Expectations. So, this is the famous nano porcelain wares or the rose pompadours made by the manufacturer National D. Sabres. Thanks a lot for listening to me. Thank you.